Our first speaker this morning is Nina Stachenfeld from Yale University, or Yale School of Medicine.
Thank you, everybody, and thanks so much for inviting me to this. As you might guess from the title, my talk will probably be slightly different than most people's. I work exclusively in humans, and I did hear the comment before that it's easier to work with animals than humans. And I'd like to just point out that there's some truth to that, but I know that none of the women that I work with, and I work primarily with women, but I would say this is true for men as well, that none of them have ever bit me. I'll start out first by acknowledging some of the important people in my professional life. The top person there is the late Ethan Nadel, who brought me to Yale and was one of the foremost environmental physiologists of his day. And also Dr. Hugh Taylor, who has really helped me. He's our chair of OBGYN and has helped me a great deal with being able to do some of the manipulations that I need to do with hormones. One of the ways humans are more difficult than animals is that they tend to refuse ovarectomies for no good reason. So we have to find other ways of controlling hormones. I'm going to start out this talk, which was titled Sex Differences, by pointing out, first of all, how similar the sexes are with regard to cardiovascular disease rates. And if you look at these two maps, I apologize, they're slightly different years, but they overlap quite a bit. And you can see that as bad as cardiovascular disease is for men, it's equally bad now for women, and that the patterns also with regard to where the cardiovascular disease crops up is similar across the country. And as I'm sure this group already knows, that the primary risk factors for cardiovascular disease, the first one, and I have it in red, is hypertension. And then we see these other three, which are related to what we're discussing today, but we're not really directly discussing them. But I also want to mention that 49% of Americans have at least one of these risk factors. Specifically, cardiovascular disease in women, just to give you an idea of the magnitude, is about 1 in 3 United States adults have hypertension. And hypertension is the strongest risk factor for cardiovascular disease, and this is the leading cause of death in the United States. Cardiovascular disease is also the leading cause of death for women in the U.S., and it kills almost 300 million people, 300,000 women in 2009, which were those data that I had up before. It's responsible for 25% of female deaths. And many women are living with cardiovascular disease, and that's nearly half of all African American women, which is quite a staggering statistic. In 2009, women accounted for over 50% of total deaths due to hypertension in the United States. And it also has quite an extremely high death rate of 8.5%. So I think I'm making my point here. And we've seen overall a decline in heart disease death rates among men over the last 25 years. And this is also apparent in women, but at a much slower rate. And this has been addressed by other speakers. Let's see if I can. But you can see that blood pressure rises throughout life in both men and women. But you can see after 40, the rate that it rises in women is much, much faster than it rises in men. And that increase in hypertension actually precedes this area here where we see the cross, and we see that later in life women actually exceed men in the population with cardiovascular disease. So the other points I want to make with regard to cardiovascular disease and hypertension is that you can see through these slides as well that after menopause, blood pressure increases. And as I showed you on the last slide, and this slide brings it home as well with regard to looking at the dividing this, examining it within races, that you can see that they develop, as they get older, they develop high blood pressure at a higher rate than men do of similar ethnic background and race. And what are the causes of hypertension and cardiovascular disease in women? One of the things that struck me when I was reviewing the literature is how more sensitive women are to changes in BMI or body weight as they get older. And we all have recognized that obesity and increases in body weight are important predictors for cardiovascular disease. But if you look here at these graphs, you can see, whoops, that's what I get for trying to use the mouse. You can see that the rate of increase with regard to BMI here, that the women are much, much more sensitive to the changes that we see naturally with aging, with BMI. And I was disappointed to find out yesterday that the endothelium doesn't really look like this, because this is so much easier to look at. I was happy to see that it has lots of different colors. But in any event, endothelial cells are important with regard to my talk because they release these important substances, including nitric oxide and endothelin-1. And the endothelin-1 issue is one that I'll address because the impact of endothelin-1 is really different between men and women. And we know that vessel tone is balanced by these and a number of other substances that are very much involved with the control of blood pressure. Just to diverge for a minute, as I mentioned to you, I work in human beings, and that means that we have to find non-invasive ways and models to study different changes and effects on blood flow. And the previous discussion, it did come up about the idea of being able to study these kinds of questions in human beings in a non-invasive way. What I'm going to show you is not imaging, but we use the skin as a model of cardiovascular function or microvascular function, and this, by doing so, it allows us to an opportunity to ask mechanistic questions in humans. And what I'm showing you here is just a picture of the skin. And if you look down here, you'll see blood vessels in the subcutaneous layer. And that's really where we're looking. We use laser Doppler probes, and this is just a picture of those probes on top of the skin. It's hard to see in those, but in case the probes are inside very small heaters, and that allows us to heat the skin up while we're doing our experiments. And one of the reasons that we heat the skin is because most of vasodilation due to local heating is controlled by is an endothelium or endothelial related process. And we know this because when we infuse L-name, it doesn't completely, but almost completely is diminished. So basically this very first layer here, which we call phase 1, is a very fast response vasodilator system, and it's mediated just by axon reflexes. And you can see that this starts to fall down. Some of our subjects, it goes all the way down, and then it comes back up. And this second section here is the area that's mediated by nitric oxide. And this is a picture of the skin and its many mechanisms of microvascular control. And I'm really interested in just two areas here. This one here and this one here. If you look, you can see that for the purposes of my experiments, I'm dealing with endothelin-1. And endothelin-1 operates using two receptor subtypes, ETA and ETB. And in ETA and B are both found on the vascular smooth muscle right here. And when they're activated there, they mediate vasoconstriction. However, in the endothelium, also you see ETB receptors expressed, and under those circumstances, it mediates vasodilation. So this is a picture of what our experiments look like. What we do with our studies is we use microdialysis probes, which are these tiny probes right here under the laser Doppler probes. We insert these into the subcutaneous layer of the skin, and then we can infuse, in this case, we've infused BQ788, which is an ETB receptor antagonist, as well as BQ123, which is an ETA receptor antagonist. We can basically do this, we can infuse this with a myriad of chemicals depending on the hypotheses being tested. But here we were specifically looking at the impact of these two receptors on skin blood flow. And in this case, all of our studies were done in women. Actually, I'm going to backtrack for just 1 second. A very similar study, which was conducted in men and women, was done by Kellogg. And it was actually this study that got me sort of interested in ET1 effects. And in this study, and I'm guessing it was a little bit of a surprise to them, they were testing resting skin blood flow using the same technique I just showed you. And they found that the responses to BQ788 or ETB antagonism differed between the sexes. And they specifically demonstrated that when they infused the ETB antagonist, they initiated a vasodilation in the men, which is what you would expect if the ETB receptor is mediating vasodilation, or excuse me, vasoconstriction. But and it actually so that worked out just fine in the men. When they examined this BQ788 in the women, however, they demonstrated that it indeed was mediating vasodilation. So, in other words, this ETB has different effects on men and women, and they speculated that this is probably due to a greater expression of ETB receptors on the endothelium. And in the men, primarily, they were expressed on the vascular smooth muscle in the men. This is the study that I was just showing you in our lab. We wanted to replicate his study, but do it using dose-response curves to make sure that we saw the same thing. And we also wanted to test the effects of ETA receptors in women. And we found basically what Kellogg found. This is a graph showing change in skin blood flow measured with a laser Doppler probe during dose-response curves of BQ788. And you can see this is the men and this is the women. The blue is the women. And you can see that they had exactly the same response, that during ETB antagonism, as expected, the men in the study increased, showed a vasoconstriction, and showed a vasodilation rather, and the women showed a vasoconstriction, basically replicating what Kellogg found. And with ETA, as we would expect, because ETB receptors are not expressed in the endothelium, we found exactly the same responses in our men and our women. So again, we would support the expectations that these differential responses suggest a predominance of ETB receptors on the endothelium in the cutaneous circulation in women, and they mediate there the vasodilation. And these data would also indicate that ETA and B receptors on the vascular smooth muscle in men mediate vasoconstriction. Since I was asked to also discuss the effects of hormones as well, I wanted to share some other similar data. Just reminding you, we used exactly the same types of studies. We used laser Doppler with microdialysis, and we wanted to compare our control women, control healthy young women, with women with polycystic ovary syndrome, and they're an interesting population. Women with PCOS tend to almost always have insulin resistance, and we screened our subjects to make sure all of our subjects did. And they tend to also have high levels of testosterone. Ooh, okay. High levels of testosterone. And so we wanted to compare the effects to see whether these women behave differently than our control women, and we found that they indeed did behave just like the control women, but with a blunted responsiveness. And this is a similar slide, and I'll just tell you that progesterone, this is all in control women. This is during a suppression of ovarian function using GnRH antagonists. So that's our way of sort of medically oophorectomizing women. And we demonstrated that progesterone administration enhanced adrenergic responses in women with high but not low tolerance. So this was definitely a response that was integrated with the ability to regulate blood pressure. And we didn't see this in women with low orthostatic tolerance. And I'll skip this because I'm out. And the lessons learned. The cardiovascular disease is the most common cause of death in both men and women in the United States. And I wanted to hopefully get across to you that we can study primary risk factors and their mechanisms directly in human, including endothelial and autonomic function, which I wasn't able to show you that last bit. Blood pressure in women is especially sensitive to changes in body weight. Risk factors in women increase after midlife and appear related to changes in blood pressure, and that this rise in blood pressure after menopause is sympathetically mediated. And both autonomic function and peripheral microcirculation are sensitive to hormone exposure. And I have a lot of gaps in the field, especially in humans. It's always a challenge to become more mechanistic. One of the ways we're trying to do that is by drawing endothelial cells using J-wires, and then working with my molecular biology colleagues to try to examine some downstream mechanisms that may cause the differences, specifically right now in women with PCOS and the ET1 effects. And I guess I'll stop there. Thank you.
So we have a time for two questions.
Brief.
Did you attempt to perform any dose response curves to endothelin 1 or to a ETB agonist, a cephalotoxin?
We are in the process of those ET1 experiments. I think when I get back, our IRB will approve those. But yeah, that's the obvious thing to do next, which is to infuse ET1, you mean, in a dose-response manner and use our antagonists.
Yeah, so do you think that in men and women there's a different endothelin tone that results in these variable results with BQ788 and BQ123?
Do I?
Yeah.
Yes, I do, yes. But
Wow.
I think we need those experiments to demonstrate that.
Mm-hmm.
Bob?
So do you have any anatomical evidence about the location of these receptors? And the reason I'm asking is, on occasions in cerebral vessels, we have seen when we give an ETB agonist luminally, we get no response unless we block cyclooxygenase. And then we see a response. So I'm wondering if there could be a endothelium contracting factor involved in this.
No, that's interesting. That's interesting. I mean, there is evidence for in vessels regarding the location of those, but as you saw in that diagram, the prostaglandins have an enormous effect on blood flow in the in the skin, and also that is definitely different across the sexes, or different related to hormone exposures, specifically progesterone.
So Mark, you want a last quick
Sure.
question?
Quick one. I probably missed it, but when you're warming and blood flow goes up, my thought was that the increase in blood flow was due to an effect on the keratinocytes, which then release things that affect the blood vessels, and there's specific effects on various types of B3 channels and B4. And the keratinocytes also have endothelin receptors. So how do you know what cell type you're looking at?
Well,
And not the effects of the keratinocytes?
Well, the experiments that I showed you with the ET1 receptor, with the ET1 experiment, were not done during heating. There was a very small amount of heating below any change in blood flow, just so that the area that we have to use is the forearm, which starts out with a very low flow. So we didn't want to hit a floor effect with the ETA studies. But we weren't really heating them and causing a big vasodilation and stimulating that whole system during those studies.
Still, I mean, you always wonder if the effect could be indirect through some other cell types that you're not looking at.
Absolutely. It's a messy system in there.
Thank you very much. Great talk.